Anyone applied yesterday that intern openings, DevOps intern? No, no.
That's only for the class or our officer also is fine. I mean, my friends that they can have some.
Generally, they'll not send. They'll choose partiality. No? Okay, that's fine. But they're asking for 6 months intern, it seems. Okay, join it, and if they'll ask for bond, also join. Okay, 6 months they'll not give any salary, it seems. Join first. At least without paying, also we need to get job now first. Then after that, paying jobs will at least. By the time we'll complete the course, parallel you can try other things also. Okay, those are freshers I'm telling clearly. Okay, experienced people maybe you can do something and you can jump. That's fine. For freshers, you can try at least. You'll get exposure. What they're asking, how we have to talk. Those things you'll get to know first thing. Okay, and say that for bond, I said no, for everything you have to say ready. If they are ask bond also. Okay, then after that we'll see. By the time if you get any other offer, now you can break the problem. It's not a great things. Anyway, 6 months they're not paying salary rate. What is that they have to ask you back? Simple. Okay, there is no problem in such case. You can proceed. Okay, and even yesterday one guy got offer, no? That is also some what is that startup company only. Okay, but 3 years experience, not fresher, 3 years experience. He added full experience. Okay, but for him it's second offer. First offer background verification gone. He doesn't know how to add the documents and all, so it went off. Second company got it. Anyway, that is fine. DevOps will get jobs, not a problem. After getting job, only problem. That is true. Okay. Really, that is true.
Yeah, I know. I have got enough attack from Linux admin also. Then DevOps is apart from that.
That is a common thing. Okay. So this is what we supposed to discuss as part of our DevOps. Maybe we are talking about generic DevOps. Maybe in future you may work on Azure DevOps or AWS DevOps or Google DevOps or any DevOps. The concept is same. From development to till production, we need to create a pipeline environment. Pipeline means the stage to stage connecting and will make it continuously integrating, continuously deployment. That is what CI/CD. Okay. So for that purpose, DevOps methodology came into the picture. Why this one means it is easy to make your work. Otherwise, everything running manually and deploying it's not an easy thing. For that purpose, we'll make all this as a one common thing as a pipeline and we can deliver it. That is what we'll do generally. Okay. So for that purpose, we'll be using pipelines and we'll build that pipelines. So this pipeline, as per our generic DevOps, we'll be discussing in a Jenkins pipelines. We'll write a Jenkins Groovy code and we'll build it. Maybe if you are going for a Azure DevOps, we'll write a YAML files. Maybe if you are going for some different DevOps, they'll write some different way of execution. But ultimately, you need to build that pipelines. Okay, this is what our work. To build this pipeline, we'll be using Jenkins for us. And here we have a various areas. So source code management will start with Git. That is mostly used environment, Git and GitHub. Then followed with build part, we'll be discussing anyway Docker. And same deployment will be using the same Docker and Kubernetes. And then followed with Ansible for automation. And cloud deployment will be using the Terraform. Okay, those are the tools will be covered as part of the DevOps. and all these tools will be practicing on the cloud. You can use your cloud servers and you can practice it. Okay, don't try in local. For example, Jenkins installing your Windows, don't do that. Take some cloud servers and do that because it is faster. In your local server, it will not be faster. You have a lot of blockage because I don't think so. You guys has some good enough resources locally. Cloud servers are faster. Prefer your practice there only. Okay, don't do it locally. So as part of the first tool, Git, we need to install the Git and we need to manage the Git environment. Why we need to maintain the source code management? Why? What is a necessity? Why it is important?
Multiple people are working there, so
Okay, let them work multiple people. What is the wrong in that? You don't like multiple people. Huh? Why? Why we need to use? Okay, tell me one thing. So you know that how to create this files and directories, right? Right? Huh? Okay, fine. Can you make out who is modified this last file? Here we have multiple files and the directories now. Can you make out who is the last modified or which file is the last modified or which directory was the last modified? How to find? Here multiple contents are there in my directory. Some files and some directories. I want to identify which file is last modified. No? I want to know which file is last modified. First class asking now again. History. Yeah.
That is for commands. Last year's commands.
Some files are there in my current directory. I want to know which file is last modified, recently modified. ls hyphen lh.
LT.
ls hyphen lht. Anyone is there in morning class? Today morning class? No, right? Then I can ask one question. So how is the files are listing? Based on the size I want to list out. Yeah, ls. Size, based on the size I want to filter.
You already told in this class.
That is a good thing God gave. Right? Huh? So you can do ls hyphen capital S. Okay, that is a size base. Okay. Okay, fine. Let's come to our concept. So I want to list out based on the time order. So you can find some file which is recently modified is that a scripting directory something recently modified. After that, some sample.txt file recently modified. Just take a sample.txt is a recently modified file. So can you make out what is modified inside the file? How?
More by using more command.
You can make out more command sample.txt. Tell me which is recently modified. Inside file, which content is newly added? It's saying recently modified file. Something either added, something either deleted the content, right? I want to know what is the content deleted. Assuming that this server I gave access to all of you guys. Okay, as a root user only, everyone is logged in. Everyone is modified sample.txt only. Last she modified. She logged in. Something she deleted. I don't know. I need to track who is modified. Is it possible? Either you take either Linux or Windows anywhere. You know how to track the last modified file or a directory, but you can't track what is the content inside modified. Will you make out? Sorry? Windows we can make out.
Windows in Excel or anything, we can find out who is lost.
1 minute, let me open Excel. I want to know, na? Okay, downloads folder is there. Tell me which is recently modified. This is recently modified. My bank statement. So now, will you able to tell what is modified inside?
We can't know what is modified, but we can know
I
who
want to
is
know.
modified.
No. I want to know what is the content, right? Content is important. I want who is modified. For example, see, this is the document file. It's a document file. Last I only opened, but whether I content added or deleted, that you can't track. That information definitely you don't have. OS level, you don't have that intelligence anywhere. Got it? Clear? First, what is the problem you understood? Then we'll look for the solution. So in the OS level, you can able to make out what is the last modified content you can modify. I mean, the object you can identify, the file or a directory. But inside the file, what is the content modified, you can't track. It says that last modified done, but whether the content is updated or deleted or modified, no, we can't track it. OS level, we don't have that intelligence. Okay. So then there is a concept called a version control system. Okay. Using that version control system, we can able to track the code changes. Code means nothing but some text. You are writing in a one file and making it, but it is important for our application. Got it? This is sample.txt, some content is there. Maybe you're writing some story, no one is interested, but code is interested. She modified something. According to that one, some operation will be working there or some functionality is working. It is important for me. Code is important. Now take a scenario that I have maybe like you some 100 developers are there in my project. Okay, so my project is running. Now some bug came. All these 100 developers, they worked very fine. They developed the application, they delivered to the customer. After delivering to the customer, once customer is logging to the application, login is failing. Even they enter correct credentials also. Now whom I have to blame? If I pointing her, she'll tell that I written the super code. Everyone will tell the same thing. No developer will accept that my code is wrong. They'll never accept. Whom I have to blame? When I have to blame? Things are like that. Okay. Once it happened in my organization only, some 4 or 5 years back. So we are in a telecommunication, like how we are using Airtel, this one, like that. So one of my developer wrote the code on the Friday evening, hurry burry, pushed the code. Build failed, multiple times pushed, failed, multiple times pushed, finally pushed. So Friday night, at that time, Russian team also there, they do the builds. Build is completed. So Monday morning we release it. It is on the month end. So we release it. It's maybe some July end. July, after October, after July. July, after the August. After August, September. Okay, August we release it. September first week, they came back with some $4 million fine. $4 million. Approximately 25 crores. Okay, that is the fine. They came back. So what happened? The story. 1 month, after 1 month, immediately they came back. Okay, fine. After 1 month, they came back. What happened? So this is the telecom, right? So 1 month they run the business. My application will be running on the billing time. So what happened is, so for example, she is a international user. She's got a ISD bill. This guy is a local user. Get a local bill. Assume that. So she get a local bill. She paid. This guy got a international bill. This guy went to court. Bill got changed. Now, as a company, I can't recover from her. Why? I only sent bill legally. She cleared also. Okay. She can able to claim, even she can claim legally on me. Some false argument, something she can claim. This guy also will file case on me only. Got it? Huh? So ultimately company will be under loss. Now why this kirikiri happened? That developer who pushed the code on Friday night, Haribari, right? What happened is, in Java we have local variables, global variables, right? Right? Instead of using local variable in his code, he's a web developer. He used global variable. Done. Okay, then testing, what testing is doing? Testing has to test, right? They tested, not found. Why not found? This issue will come from after 7th user. First 6 users, no problem. First 6 users bill is correct. 7th user onwards, the bill will be problem. It will do that mismatches. So testers, how many times they'll test? 1 time, 2 time, 3 time, 4 time. They'll say very good, done, approved, went. 7th time issue came. Then we need to identify who is the developer did this great change. Where is the track? If someone they written the file like this, and I blame some developer, will they accept? Definitely no. So we need some tracking information. So if my file is there, some file is there, that file, why you are modifying that code, you need to give the justification. For that one, we have some tracking information like Jira ID, some ticketing system will follow. Based on that ID, you will be saying that because of this particular code change, I'm updating this file. Because of that one, I'm adding something, I'm deleting something. Then later it will be review, testing, all those things will be happened. But first we need the tracking system that can be managed via version control tools. It can be SVN, Git, GitHub, Bitbucket, TFS, whatever it is. Why I'm talking only Git is, Git was introduced in, while Linux is developing, Git was introduced. Who that same guy, who developed the Linux, na? That Linux, that guy only developed. Because it is tough, na? See, developing application means some 5 or 10 files, okay. But operating system means some use code. Definitely I can't remember what I did yesterday, today I will not remember. Even if intelligent, of course, generally I will not remember. Think that it is a big code. How it is possible? It's not possible. What you updated yesterday, what need to update today, that tracking can't be happening in a regular files. In that scenario, our version control tools come into the picture. Okay, there we can able to track each and every change. I'll show you a simple thing today. We'll discuss in detail on Monday class. Tomorrow we'll take leave. Okay, some weekend break we'll take. Rains are there, no? Flood effect.
So company paid that 25 crores.
Which one?
That I was also going to ask you. What about the bill?
Bill, oh, that fine, fine. What happened is they send with $4 million. That's what management you have to. You should be in the management. Then only your manager importance. So they bargained for some further licenses. Someone joined. Who is that? We'll say welcome. Who is that guy? No one. No? Okay, fine then. So finally what happened is there may be some license agreements. So they want to give some further releases, will be some extra license, will give free something, they bargained. Somehow it has happened, okay. But yes, definitely it is a tough, it's not easy thing, okay. That is the problem. If you are finding the problem and you are fixing internally, no issues. Client find a problem, no? It's a problem. They'll going to file severe things. That is a problem. Okay. For that one, you have to make your product stable. Okay. Anyway, fine then. So first thing is, let me create Linux. Okay, here I created various directories. Okay, I'm creating some simple directory, mkdir my app. Okay, my app directory I created. It's a normal directory, you can see, nothing is there. It's a normal directory. Inside this directory, if I make any changes, I can't track it. Definitely, no right. So we have one tool called Git. I'll explain in detail history about the Git and the version control types and all those things in the next class, but we'll see the how it will be helpful for our tracking purpose. Okay. See that. So to install the Git, go to that git -scm. This is the site you have to go.
For installation.
Installation. If you want to install, you can install in all our environments. So download for your Linux, Windows, Mac, everywhere you can able to install. There is no restriction. It's a very simple tool. Okay. So maybe I'll send you this one to you. Okay. Fine. So there you can download the tools. Maybe Windows means you download .exe file and install. Then you'll get that bash window and all. Linux means simple. You can run a command yum install Linux. I'm sorry, yum install Git. So at 99% it is available. If not, you had the repo and it will be installed. 99% it will be done. Actually, here it will not happen because my server has a problem. Okay. It's failed to download some repository and all blah blah things. Anyway, that's fine. So Git is installed in my environment. Okay, you check the Git version. It's 2.31, but latest version. What is the latest version? 2.381. See. Okay, so you need to upgrade. But my machine I have a problem. That is the reason. Anyway, that ignore it. That's fine. So Git is installed. So using this Git, we can able to make a version control system. First, we need to create a repository. What is a repo? Repo is nothing but don't think anything. Repo is nothing but one directory where it contained all your information. That one generally will call as a repository. Git repository, Docker repository, container repository. Everywhere we'll call that repository. Repository is nothing but a collection of your multiple objects. Nothing but a file. Okay. So now I'll make this as my Git repository. So you have to do initialization. Okay, Git init. Now see ls-a .zip directory created. Na? Inside that directory, it can able to track all your code changes. What you modified, what you updated, all those things it can able to track. Okay, if you see inside that .zip directory, you can see again some information, config information, hooks, info, object references, all that information you have. So using that one, we can able to track that all the information. Okay. Let's see. So run a command called git status. It shows the current directory status. No commit set. So no change happened and no commit sets. It's a clean repository. We'll make some change. I'm creating some file called some script.sh. I'm creating. Okay, I can track, but Git is not able to track this one. So Git status. Okay, script.sh. What it's showing? It's showing is a untracked file. File is not tracked. Okay, so this file has to be tracked. For that purpose, git add your content name. File is tracked means that file I added to Git repository. Now Git database can able to recognize that file change. Then you have to commit your change. Committing means confirming your change what you did in your repository. So git commit -m. M for message. I'm giving this message only how to give the proper message. Based on that one, yes, we can able to confirm it. Example, see that I'm giving some message that created a script file. Done. Now see git status. It's clean, nothing is there. Now run git log. So it's showing, see that what it's showing the commit ID and other details you need to update. How to update means you need to run a command called git config It's not there. I global. It's not there. Git config hyphen global user dot name, and your username you have to give something. Similar way, user dot email you have to give your email. This is for your information. What are the information? Your username and email ID that you provided. Then that is what you are showing here. Git log. That other information. Okay. And the timestamp, the message. And you see that commit ID. That commit ID is very unique. Every time, how many times of commits you will be committed, every ID is unique. It will not match with any other commit IDs. Based on that commit ID, I can track the information what you modified. Now let's see, I'll modify the file. So I'm adding some script. Okay, saying echo hello git. Okay, something. Okay, I modified. See the git status. Okay, then do again git add script.sh. Modified, file is modified, and do git commit. I'm giving the message that updated script something. Okay, now check git status again. It's clean, nothing is there. If you see the git log now, so we have two commits, commit 1 and commit 2. Okay, so first commit and second commit. Let's put -p, we'll get in detail information. See that. So created script file, just created a new file. Second thing, what happened? It is updated the script. See that this plus mark, green color, the content is added. I can track each and every change. Even if you modify one single character also, we can track what is modified. Maybe we'll do some other way. I'll track. Maybe I'm deleting that exclamatory mark I deleted. Okay. Again, see the git status. Again, it is modified. So git commit. I'm sorry, we need to add now. Git add that file name and git commit -m some other message deleted extra characters something. Okay, now see git log and git log -p summary will get. See that here what is happened from this message to this message it came. Okay, so we'll get in detail information about what we are making changes in our repository. That is what our source control systems can able to provide you. Okay, so in that Git why we are using is it is comes under the distribution version control system. Earlier days even we have a SVNs. Okay, that that is a what I can say, that version control system is not so accurate like as a Git. Okay, anyway, I'll give that comparison next class. So using this one, we can able to track our code changes and we can make it. And now whatever I created, it is a local, only belongs to me. Within my system, I created this repository, I'm managing it. Now I want to manage remotely. In that case, we'll create any cloud-based accounts like GitHub, Bitbucket, GitLab, any of those things. In my environment, I'm maintaining the Git server only. To managing all the Git repositories, I'm maintaining the Git server only, not cloud-based one. Of course, now we are migrating to the GitHub, but till now, I have my own Git servers. I'm maintaining my Git hooks, everything. Okay. So that is what our version control system we can able to make it. There we can able to give the permissions to the user and deleting the users, adding the users, giving the certain access, all those things we can able to make it. Okay. Even you can try that. Last time I sent na GitHub account. Okay, try to access that one also. That is what the account will use it and will able to commit, pull and push our changes. That is a remote. This is local thing. Okay, and even let me show you that intro. This is the document. It's a good document. This is local version control and centralized and distributed. So we are talking about the distributed. This is what we are talking about. Okay. So here, if you see, olden days we have a centralized version control. Centralized version control, what happened is that SVM, we have a centralized server. All users, they're developing their code and they're pushing that code to the centralized repository. It will collect here. But whether that code is related to some file in the starting or beginning or ending, that can't be recognized by your what is that repository. There we have a lot of conflicts used to come. But coming to the distributed version control system is totally different. How it will work? For example, assuming that I have a centralized repository, I am the owner for that repository. I hire these two developers, for example. Okay. And what they have to do, they have to develop the code and they have to commit the code to repository, centralized. I mean, remote repository, not centralized, remote. In that case, you can treat computer A, computer B, user one, user two computers, that is, okay. Remote and the server side, my repositories are there. Generally, in centralized model, what happened is anytime developer one can push the code to centralized repository, developer two also can push the centralized repository. No issues with respect to the pushing the code. But coming to the distribution version control, it will not do that. Here we are calling as a head. See the head. Head means the top code. Head means the top level, right? That one we are calling as head, means the recent commit. Head means in distribution version control system, that head will be considered. Developer one is pushing the code to remote repository, for example. Before pushing her local repository, my remote repository should match the head. If head is not matched, I'll reject. It will not take that build, that commit it will not take. Saying that your local repository is behind some commits, not matching with the heads, reject. That will happen. That is what that distribution version control system. Centralized, that is not the case. But distribution version control system, we have that is the case. It is more accurate. Take a scenario. Developer one written some code. Maybe both are working some only one same component, same file. Some change is making it. So developer one make the changes. Everything is updated. That code is committed and push it to remote. So her local commit and my local commit is same. I mean my remote commit, developer one. Now developer two also developing the same kind of code in her local, but she pushed after a minute before the developer one. Okay, so developer one pushed first, developer two will be the second. And now same file, same code changes. She trying to push. It will not happen. Why? Because now her local head commit and remote head commit are different. My remote head commit is already updated with the developer one code change. These two are in matching. Both are up to date. Now developer two wants to commit that change. What she has to do? First, she has to pull from remote to local, should be up to date. Then only you can push the change. Otherwise you can't. That is what the distribution control system. This one. So always your versions must be up to date. And if it is up to date between both the computers, means both the users code also up to date. That is what distributed mechanism. Okay, centralized mechanism, this model was not there. It's not accurate. So you will get many conflicts, many errors. But here, this is more accurate one. That is what we can make it. Okay. So using this one, we can able to make our code changes and can do that one. Okay. That is what we can able to do. Clear? This is what Git is working. That is the reason Git is more smarter compared to other version control system. That is the reason you take either Azure cloud or AWS cloud or maybe some GitLab or Bitbucket, anything, they'll taking the Git is the main reference. Git is open source. Open source, free, you can use it and you can able to manage. Okay. So this you can able to install in your locally, maybe in your Windows machine or your servers or your MacBooks, anywhere you can install and you can manage the repositories. Okay. Keep in mind that the main purpose of the Git is to track your code changes. That is version control system we need to maintain. So we saw only now locally. So in the next class, we'll see the remote repositories and we'll see how remotely it is up to date and managing it. Okay. Here a lot of concept is there. If you want to discuss, we can discuss for 1 month. Version control system. That much scope is there. Okay. Fine then. I'm sending this document. This book is good. This is official book. They explain very well. Okay. You can look into this one. Okay. So let me send you that file to you guys. Still I have some more. Let me send you those things also.
Theory.
No?
Theory part.
That is all theory documents. So this is architecture, commands. Yes, that one also you can see. Okay, get majorly all the commands where you have to use to automate your version systems and tracking your code changes, all those things. Okay, and here the other major important thing is your branching strategies. How will create your branches? How will you managing your branches? That is the important part. Okay. So now onwards, it's important concepts, mandatory. You will expect all these questions in interview. Okay. Now onwards, commands, how are you are understanding or not based on the our Linux grip. Scripting is based on the scripting basics. Okay. Now onwards is the our main tools. Okay. Fine then. I'm stopping today. So tomorrow we'll skip. Okay, because even 5 o'clock class is also not there for me. So we'll skip to tomorrow. Monday we can connect. Okay. So weekend if you want any task. Free, right? Weekend. Huh? Fine. Huh? We'll connect. Huh? Let me close the call.
Sir, I have created the Git account.
GitHub. Huh? You created a login. Huh?
No.
Huh?
You have to send me that invitation.
Then send me GitHub IDs. Your GitHub ID send me. I'll add you there in the repository.
Chat.
Send in Skype. No? We created group, right? Okay, send me. I'll add you in that group. Okay.